Have you ever just looked up at the night sky and thought about well, all the invisible stuff happening? Like a huge cosmic dance that could just, you know, light everything up.
Yeah, it's pretty mind-bending when you think about it.
Exactly. So today, we're doing a deep dive into one of the most spectacular examples of that, the Aurora Borealis. You probably know it as the Northern Lights.
An absolutely stunning phenomenon.
Right. So our mission for you today is basically to unpack it all. We want to get into the science, figure out the absolute best times and places to see it, maybe give you some practical tips if you're thinking of going,
Hmm.
and even touch on some of the cool stories and experiences around it. We've looked at a bunch of sources to kind of give you the shortcut here.
Yeah, synthesize it down.
So, okay, we know they look incredible, that sort of magical dance people talk about, but like, what is the Aurora Borealis, really? What's actually going on up there?
That's the perfect place to start. Because, yeah, it's a light display, but the why is all about physics, cosmic scale physics. Uh, Basically, you've got these charged particles, solar wind, streaming off the sun.
Okay, solar wind, got it.
And sometimes, especially after a big solar flare, you get a whole lot more of them hitting our way. Now, they travel millions of miles, and when they reach Earth, they run into our magnetic field.
Which acts like a shield, sort of?
Exactly, but it's not a perfect shield. It actually funnels these particles, guides them towards the north and south poles. That area, scientists call it the auroral oval.
Auroral oval, I like that. Okay, so they're funneled to the poles. Then what? How does that turn into, ribbons of light?
Right, so as these particles, which are super energetic, plunge down into the upper atmosphere, they start colliding with gas atoms and molecules up there. Think mostly oxygen and nitrogen.
Ah, okay. Collisions.
Yep. These collisions transfer energy to the atoms, exciting them, kicking their electrons into a higher energy state. But, this is the cool part, they don't stay excited for long.
To calm down.
Pretty much. They drop back to their normal, lower energy state almost immediately. And when they do that, they have to release that extra energy they absorb
Like with light.
as light. That's the aurora. That's what you're seeing. Each little flash of light is an atom releasing energy after getting smacked by a particle from the sun.
Wow. And the different colors. That's tied into this too, isn't it? It's not just random splashes of paint up there.
Not at all. The colors are like specific signatures.
Yeah.
They tell you which gas is being hit and roughly at what altitude. That really common, beautiful green,
Yeah.
that's usually oxygen atoms being excited at lower altitudes, maybe, say, 60 to 150 miles up.
Okay.
The red, which you don't see quite so often but can be spectacular, that's also oxygen, but it's happening much higher up, like above 150 miles.
Higher up, different color. Gotcha.
And then you get blues and purples sometimes, maybe deeper violet hues. Those are typically from nitrogen molecules getting excited.
Huh. Knowing the science behind it almost makes it more magical, doesn't it? You're actually seeing atomic physics playing out across the sky.
It really does. It connects the sun, our atmosphere, and basic physics in this incredibly visual way.
So let's shift gears a bit. For anyone listening who's now dreaming of seeing this, where should they go? When's the best time? What's the strategy?
Right, the practical stuff. Well, rule number one is you got to head towards the poles, into that auroral oval zone we mentioned. The sources we looked at really highlight places like Iceland and Norway.
Okay, Iceland. What are the good spots there?
Iceland's great. You've got Thingvellir National Park. It's actually pretty close to Reykjavik, which helps. Then there's the Jökulsárlón Glacier Lagoon, which is just stunning visually anyway.
Oh, I bet.
Akureyri up in the north is another good base.
Yeah.
And if you want really dark, remote skies, the West Fjords region is fantastic for that.
And Norway. It feels like the classic Northern Lights destination for a lot of people.
It really is. Norway's got some legendary spots. Tromsø is probably the most famous, often called the gateway to the Arctic. Has lots of tours, good infrastructure. Then you have the Lofoten Islands. Imagine seeing the aurora over those dramatic mountains and fjords. Just incredible.
Wow.
Alta is another major hub, sometimes called the City of the Northern Lights. And if you really want to go remote and maximize darkness, there's Svalbard, way, way up north, deep inside the Arctic Circle.
Okay, those sound like serious bucket list locations. So let's say you've picked your spot. What about timing? When's the magic window?
Good question. You need darkness, obviously. So the main aurora season runs generally from September through to about April. That's when the nights are longest.
Makes sense. Winter months, basically.
Exactly. And within a given night, your best bet is usually, let's say, between 10 p.m. and 2 a.m. local time. That tends to be the peak activity window, statistically.
10 p.m. to 2 a.m. Okay.
But, and this is absolutely critical, you need clear skies. Clouds are the enemy of aurora watchers. And you need dark skies, meaning you have to get away from city lights. Light pollution is a killer.
Right, that washes everything out, I imagine. So, okay, let's get into the nitty-gritty. For someone actually planning this, what are the must-know tips beyond just being in the right place at the right time?
Definitely. First, like we just said, get away from town, find the darkest spot you can. Second, check the forecasts. Not just the weather forecast for clouds, but the aurora forecast.
There are aurora forecasts.
Oh, yeah. There are websites, apps. They predict the level of geomagnetic activity. That's basically how disturbed Earth's magnetic field is by that solar wind. Higher activity means a better chance of seeing strong aurora. So you want clear skies and a good KPB index, which is the measure they use.
KPP index, got it. Check the forecast. What else?
Patience. Huge amounts of patience.
Honestly.
Seriously, the lights don't just switch on at 10 p.m. sharp. You might wait for hours in the cold. It could be a faint smudge that slowly builds, or maybe nothing happens that night. You just have to be prepared to wait.
Okay, patience is key. Bring snacks, maybe.
Definitely bring snacks.
Yeah.
And a hot drink in a thermos.
Oh.
And if you want photos, you absolutely need a tripod.
Ah, for the camera. Why specifically?
Because to capture the aurora well, you need to use long exposure times on your camera, meaning the camera's shutter stays open for several seconds, sometimes even longer, to gather enough light. If you try to handhold that, it'll just be a blurry mess. A tripod keeps it perfectly still.
Good tip. Essential, really, for photographers. And the cold. You mentioned waiting in the cold. How cold are we talking?
We're talking potentially very cold. Depending on where you are and when, temperatures can easily plummet to minus 20 degrees Celsius, that's minus 4 Fahrenheit, or even colder, especially with wind chill in places like Svalbard.
Wow. Okay.
So dressing warmly isn't just advice, it's critical. Layers are your friend. Good insulated boots, gloves, hat, thermal underwear, windproof outer layer, the works. You need to be able to stand still outside for potentially hours without getting dangerously cold.
Right. You want to enjoy the show, not just endure the cold. Okay, that's super helpful practical advice. But it's not just science and logistics, is it? There's this whole other layer, the history, the mythology.
Oh, absolutely. People have been watching these lights for thousands of years, long before we knew about solar wind and magnetic fields. And they came up with some amazing explanations.
Like what?
Well, the name itself, Aurora, comes from the Roman goddess of the dawn. So there's that ancient connection. And in Norse mythology, it gets really epic. They believe the lights were reflections off the armor of the Valkyries.
No way.
Yeah, the warrior maidens carrying fallen soldiers to Valhalla. Imagine seeing that shimmering light and thinking that's what it was. It gives you chills, doesn't it?
It really does. It connects you to how people must have felt seeing this hundreds, thousands of years ago. Pure awe and mystery.
Exactly. And it wasn't just in the north, remember. The same phenomenon happens in the southern hemisphere. The Aurora Australis, the southern lights. Same cause, just near the South Pole.
Right, the southern counterpart. And now, today, people aren't just like standing out in a field hoping to see it. There are entire experiences built around it.
For sure. Tourism around the aurora is huge now, especially in places like Iceland and Norway. You can go on guided aurora hunting tours, where locals take you to the best spots based on the forecast.
That sounds useful. Take some guesswork out.
It does. There are also Northern Lights cruises getting out on the water, away from all land-based light pollution. And then there's the really unique accommodation.
The glass igloos.
Yeah, sleeping in specially designed glass igloos or domes, so you can lie in bed and watch the sky. It's become incredibly popular.
I can see why. That sounds unbelievable.
And for the more adventurous, you can do things like snowmobiling tours or even dog sledding adventures at night, hoping to catch the aurora while you're out. It combines the landscape, the activity, and the light show.
That really elevates it from just watching something to truly experiencing it, doesn't it? Immersing yourself in that environment while the lights are dancing overhead.
It really does. It makes it a much more profound memory, I think.
So, thinking back on everything, we've gone from, solar flares millions of miles away to these tiny atoms getting excited in our own atmosphere.
Right.
To planning trips, packing warm clothes, finding dark spots, and connecting with ancient myths and these incredible modern adventures. It's this amazing mix of hard science and, pure wonder.
It really is. So what does all this mean for you listening right now?
Yeah.
I think it's just a fantastic reminder, isn't it? That something so huge and complex happening way out in space with the sun and Earth's magnetic field can create something so incredibly beautiful, so personal, and so universally awe-inspiring right here above our heads. It's physics, but it feels like magic.
Perfectly put. And maybe a final thought to leave you with. As you think about the Northern Lights, maybe wonder what other huge cosmic things are going on out there, things that are subtly shaping our world, or maybe creating beauty we haven't even noticed yet. It just speaks to how connected everything is, doesn't it? Our little planet and the giant universe around it.
Thank you for watching. Please subscribe.